My name is Kyle Ruddy, and thank you for joining today's live stream event. Today, we are very excited to introduce the latest version of the Cloud Development Kit for Terraform, otherwise known as CDKTF, which is now generally available. Joining me today is Dan Barr, Technical Product Marketing Manager, and Cole Morrison as a developer advocate. During our session, we'll jump into the latest announcements for CDKTF, see a live demo, and then follow that with some Q&A. This webinar is being recorded, and the recording will be made available after post-processing, which is generally, within 2 or 3 business days. So lastly, please type your questions in the question box, and we will answer them during our Q&A session. So with that, let's jump right in, and I'm going to turn it over to Dan.
Thank you, Kyle. So yeah, as Kyle said, we'll start off here with an overview of the CDKTF, what it is, why it is, and also how to use it. Take a look at what's new in the latest version, and then I'll hand it off to Cole for his live demo. So starting off here, the Cloud Development Kit for Terraform, or CDKTF, it's a tool set that allows developers to use familiar programming languages to define and provision infrastructure. So with this, developers have their choice of using TypeScript, Python, Java, C# or Go, while still benefiting from that full Terraform ecosystem that if you've used Terraform, you're already very familiar with. So this lets development teams use their existing and preferred tool chains and toolkits to access that full selection of providers and modules without having to necessarily learn HCL, the HashiCorp configuration language. And this really fits under, kind of one of the core design tenets of HashiCorp, which is workflows, not technologies. And the goal here is to get you and your teams towards your goal and concentrate on the workflow of getting there more so than necessarily the underlying technology. And so by providing more choice, we can enable more teams to adopt this infrastructure as code workflow. And so the CDKTF really fits under that umbrella of workflows over technologies. CDKTF is an open source project, so you can find it on GitHub. You can see the code, open issues, feature requests there, as well as see what's being worked on by the engineering team. So a little bit on how it works. The CDKTF is based on an open source project, which was originated by the Amazon Web Services team, known as JSII. And this is a set of libraries which accomplish the translation between different languages, right? So this does the translation between Terraform providers and modules into these native language constructs, and then also synthesizes the native language code back into Terraform compatible JSON. And so this open source project by AWS, it actually is the foundation of several different CDKs, including the CDKTF. The big difference, obviously, being that the CDKTF has that access to the entire Terraform ecosystem, not just AWS resources. There's a few themes around use cases as to why we developed this in the first place, what we've been hearing from customers as far as why they might want to use the CDK for TF. And the first one is really increasing developer productivity, right? That giving developers that choice of language, allowing developers to write infrastructure configurations without context switching between their programming language and HCL, or context switching between different tools, right? Development teams can collaborate in the syntax and tools they're familiar with already, which helps with speeding up onboarding of new team members. And also take advantage of their native language tooling like test kits and development environments that they're already familiar with, while still leveraging that full power and breadth of the Terraform ecosystem. The next case is using the layers of abstraction and reuse that a full programming language can bring to overcome complexity. And as projects and applications or different deployment workflows start to become more complex, we can see some teams bumping up against the limits of a declarative language like HCL, where the more powerful features of a full programming language can help streamline these workflows and also bring a large amount of abstraction and reusable patterns to the workflow. The increased extensibility point here is really about bringing that Terraform ecosystem of providers and modules into the environment that developers are already working in. And so bringing that full ecosystem into these programming languages and environments that development teams are using. And then another thing we've heard from customers who are adopting serverless applications, serverless provisioning workflows, is that it can be more intuitive to use one of these imperative programming languages for these kind of dynamic workflow use cases, and also to collapse and combine their business logic and infrastructure configurations into a single application using the same language and same workflows. So those are the kind of the main themes that we've seen as far as the why around CDKTF, and these are really the things that led us to develop it in the first place. So the natural question is, well, do I have to choose one or the other, right? Or when would we choose the CDKTF versus using HCL and native Terraform? And for us, it's really an and story, not a versus story, right? It is not an all or nothing decision. The real beauty of the interoperability between CDKTF and native Terraform is that you can make this decision on a team by team or project by project basis, right? CDKTF is a good fit for those use cases we talked about, where there's a strong preference for one of these procedural languages, when you want the ability to create these abstraction layers and you need to manage this increased complexity in your workflow. On the flip side, if you're already familiar with HCL, it's suiting your needs, keep using HCL, right? Again, it goes back to that workflows, not technology, right? Choose the right technology based on the needs of your workflow. So in kind of the and or side of things, right? You can imagine a platform team or your infrastructure team potentially creating Terraform modules of predefined infrastructure stacks that are conforming to corporate policies, best practices within your organization. And they could be developing those modules using HCL, publishing them either to the public or private Terraform Cloud Registry. And then those HCL modules can be consumable by development teams who are using the CDKTF, right? So that's an example of where both approaches can be used within a single organization. And again, it's really just about balancing the needs of your workflow, the needs of your teams, how your organization is structured, and choosing that right technology for each project. So now that we've established a little bit of the what and why of CDKTF, let's take a look at how. So how do we actually start building a CDKTF project? The first step is to install the CDKTF, right? There are two components here. There's the CDKTF CLI, and there's also then the CDKTF core library, which is the language-specific library that has all the core functionality for your application. The first step then is to create our application. We have, with the CDKTF, there are built-in templates for each language to scaffold out a project using the CDKTF command line and the init command, and that will build out the shell of your project and template out a bunch of files. One of the files that will be created in that shell is this CDKTF JSON file, which we have a screenshot of here. And this really just tells the CDKTF what language you're working in, how to build and run your application. And also importantly, it defines what providers and modules you're going to be using as part of your application code. And that information is used by kind of the next step, which is the CDKTF get operation, which will actually download the providers and generate those language bindings, the language specific classes, which you'll use in your application code. There's another option here. So since some of the large providers, right, the large cloud provider, Terraform providers, right, it can have dozens, hundreds of resources in them. They can take some time to convert. So we do also publish a number of pre-built packages for most of the popular providers, the most popular providers, which can be installed using your language's native package manager, like NPM, pip, NuGet, depending on which language you're working on. So it just really cuts down that build time because they're pre-built, they're ready to go, and they're already maintained by our team. And that's where there's another command in that CLI, the CDKTF provider add, which will first check for a pre-built package. If it doesn't find it, it'll go ahead and insert it into your CDKTF JSON here, and then proceed with building those bindings. So all that will initialize kind of the shell of our application and all the information that CDKTF needs to build and run your app and deploy your infrastructure. Now that we have that prepared, it's time to actually write some application code. So some terminology I want to introduce here. I've used the word construct here, and it's a term you're going to run into pretty constantly in the CDK. It's a pretty generic term, mostly since every construct, every element ultimately descends from the construct base class. So, when we say construct, we could be referring to anything from a single resource to a whole stack of resources to even just your entire application, right? They are all constructs. But the real power of constructs comes with defining custom construct classes that represent infrastructure configurations, again, written in your programming language of choice. These are helpful because these are, where your teams can build up custom and organization-specific resource configurations, and then also reuse those across teams, between teams, around your organization, and abstract some of those nitty-gritty configuration details away from the teams that are consuming it. So again, a construct could be anything from a single resource to defining a VPC and your cloud networking to configuring a whole Kubernetes deployment. This screenshot we have here actually comes from the team at Mozilla Pocket. So they've been using the CDKTF in production for a while now, and they've done some office hours with our developer advocacy team that Cole's a part of. They've also written up some of their information on how they've been using the CDKTF. And one of the things they've done is, they use PagerDuty for the monitoring of their applications, and they want to make sure that every one of their apps has a consistent set of monitoring configurations using that PagerDuty provider. So they created a custom construct called Pocket PagerDuty, which you can see here in this import statement. And since they've created that construct and shared it out to all their teams, all their developers have to do then is import and use that pre-existing construct. And now they can be sure that every application is using the same monitoring configuration. So that's really where the power of reusability and abstraction comes in with CDKTF is with this concept of constructs. Moving on to actually defining our infrastructure configuration in the application. This is where we're using our language of choice to define that infrastructure. We're going to use the generated classes that the CDKTF get and provider add operations have generated for us. And also is where we'll import and use any custom constructs we may have defined. And so then this is where it really becomes language specific, right? In this screenshot here again is from that demo from the Pocket team. This is using TypeScript, but again, all 5 of those languages are supported, and the entire provider ecosystem and all the capabilities are available across all 5 of those languages. Putting that all together, it can be helpful to just kind of see what this looks like, right? So we have our CDKTF application. Another concept that's important to introduce here is the concept of a stack, right? This is a terminology kind of new to the CDKTF in terms of Terraform terminology, but your CDKTF application can be made up of one or more stacks, and a stack is made up of one or more resources. And it really represents a related collection of infrastructure resources that will be provisioned by Terraform. Each stack ends up getting synthesized into a unique Terraform configuration. So this is where we can get a lot of the power of the dynamic nature of a programming language to end up creating multiple Terraform configurations. If you're using and integrating with Terraform Cloud, which is possible with CDKTF, each stack ends up representing a Terraform Cloud workspace. So there's really a one-to-one mapping between a stack and a Terraform working directory, effectively, in a Terraform state. And this is the overall workflow. So everything we've talked about up to this point has really been in this first box here, right? We've used CDKTF init to shell out our application, to generate the provider resources and to write our application. The next step in the workflow is that synthesize operation, which takes our application code and turns it into JSON configurations, which are consumable by Terraform. And this is where we have another really interesting inflection point in our workflow here, because now we have some choices. Depending on the makeup of our teams, the roles and responsibilities, who does what, we can either proceed on with the developers can actually run the deploy right from the CDKTF and immediately deploy those resources, or because these synthesized configurations are fully compatible with Terraform itself, they can be handed off to, say, an operations team, a platform team. So again, just depending on that workflow and then the breakdown of the responsibilities in your teams, you have that choice here of how to proceed with those configurations. And often, these will be wrapped around some automation, right? Part of a CI/CD process that may accomplish that handoff or push those configurations into a Terraform Cloud workspace and workflow. But again, just following that theme of workflows, not technologies, and giving teams that choice to work the way that you need to work. So with all that, what's new in CDKTF version 0.12? This is the latest release of the CDKTF. It was released here a few weeks ago. There are a few new features here to highlight. The first one, and probably the biggest one here, is Go is now fully supported. Previous versions, it was experimental, and that was really because it was also experimental in that underlying JSII project. Now that it has gone into a fully supported state in JSII, we're also now able to bring that full support to the CDKTF. So for development teams using Go, have full support for the Go language in the CDK. Another one is the team has published a GitHub action, a new GitHub action to integrate the CDKTF with Terraform Cloud workflows. So you can find that on the GitHub library. A few other enhancements around language parity, right? So we've improved the language parity in the unit test utilities that are bundled along with the CDKTF, and also brought a little more parity with HCL in the form of support for resource and block level iterators. So if you're familiar with HCL and Terraform code, we have the count and for each iterators as well as dynamic blocks. This brings those into the CDKTF in kind of the HCL context. And also another one of the commands on that CDKTF CLI is the convert command. As part of either an init process or just running the convert command, we can actually convert HCL projects. So if you have existing HCL projects, they can be converted to your language of choice into a CDKTF project. So if you have teams that make that decision to actually move from existing HCL projects to the CDKTF, you can do that using the convert command. And so, this release has just brought more accuracy to that conversion process and more reliability to it. But of course, as Kyle mentioned kind of in the intro here, right, the headline here for 0.12 is the CDKTF is now GA. So this is the first generally available release of the CDKTF. And for us, what that means is this is a production ready release, right? We are saying that the CDKTF is ready for your production workflows, and you can build those workflows with confidence and use the tool with confidence. For our commercial customers with paid support plans, this also means you now get official support, technical support for the CDKTF. So if you have issues in production, you can now leverage HashiCorp technical support to help you out with those. So this general availability, that's a big milestone. If you're familiar with the history of the CDKTF, it was originally announced, and community preview phase started just over 2 years ago, and then moved through a beta phase. A few months ago, like earlier this year, we removed the beta tag, but now we have this general availability status for it. So with that, I'm going to hand it off to Cole for a live demo of how we actually build and deploy a CDKTF application. Cool.
All righty, let me go through the process of sharing my screen. Let me get this up here. And hopefully we can see my screen, see some of these different things here, just getting things set up. All right, thank you. And for today's demo, we've got 3 parts that we're going to cover. So in this first part, we're going to set up a CDK Terraform project from scratch, cover the main concepts you'll encounter when working with the CDK, which we've seen some already in the presentation, and also build out our first piece of infrastructure. This way we can ease into the workflow and you can see how to get started. Now, in the second part, we're going to jump right into the deep end and actually build out an entire microservices architecture on Amazon Elastic Container Service. And if you're looking at my screen share here, that's hopefully working, and please call me out if it's not. You can see where we're going to be headed. It'll feature a client-facing service, 2 upstream services, a database, and everything else in between. And this will give us a view into how to go about working on something more substantial with a CDK for Terraform. In fact, you could take this project and repurpose it for your own usage, but also how to collaborate and just another way to drive home some main concepts. And then in the final part, we'll add monitoring across our infrastructure with Datadog. This is not only us being good DevOps engineers, but it'll also give us an opportunity to show how the CDK for Terraform works with any provider that normal Terraform works with, which we have driven out many times throughout the presentation, but just to make sure. Okay, but all this code is available right here on GitHub, so you can pull this down, and hopefully we can get this link thrown up in chat with every single instruction that you need to go ahead and get started. And I'll just go ahead and say what's already done. So I've already got an AWS account set up, a Datadog account set up. I have a Terraform Cloud account set up for managing state. This isn't a Terraform and Terraform Cloud webinar, but the minute you start collaborating with more than one person, you're going to need to deal with this with state, and Terraform Cloud's free for up to 5 people, so why not? And then I've also got the Terraform command line interface, the AWS command line interface, the CDKTF command line interface, all of those installed, as well as Node.js. The only other thing you might need is if you're using a different language, you'll need that runtime available to you as well. So I'm going to hop over here into my terminal, and we're going to go ahead and dive right in with that first command. And if you were paying attention to Dan, you know that the beginning here is the init, and we're also going to specify the template. So that's going to be what language you want to use, and I'm going to be in TypeScript today. So when I do this, it's going to walk through, ask me some very basic questions like my project name, description. It's going to detect that, hey, I'm logged into Terraform. Let's go ahead and set up a workspace there with my organization, set up a workspace. This is an existing project, so we don't need that. And then I'm absolutely going to send crash reports to both Daniel and Ansgar, who are on the webinar with me today, so they can take joy in as I crash things. Hopefully that doesn't happen though. Okay, so this is going to go through and scaffold out all the different files. And here at the end, we're going to see all the different commands that we can go and work with. And there's a lot here, but we're only going to focus really on 2 today because I'm more interested in sort of showing you the code and kind of giving you the mindset that you need to approach this. So let me go ahead and open this up. So hopefully you can see my screen here. In fact, I'm going to take a look at the Zoom chat to make sure that I am not missing anything. Okay, it looks like I'm good. So right here, we see along the side here a number of files. And if you've done anything with TypeScript, none of this should be crazy. And we covered some of them. Most of them are configuration files for the actual project itself. But for the most part, you're going to be doing most of your work in just your TypeScript files or whatever language files you're going to be using. And we can see here when I open up main.ts, we have in our generated template here exactly where we should start defining resources. Now, before we start coding away, I want to talk to you about the approach we're going to be taking. And the approach is if you're here, I'm going to kind of take a leap and guess that you know what Terraform is, and that in fact, you've probably used Terraform before a bit, right? And the reason I want to mention that is the paradigm we're going to stick with here as we code out this application that's going to be pretty big is the normal Terraform paradigms, meaning we're going to keep a flat file structure. We're going to stay very declarative. We're going to keep things simple, and we're going to only start adding in abstractions when we need them to be. And the reason being is if you are a developer, as I am, you build an application and you think, oh, I need an architecture pattern. Well, Over 70% of the Fortune 500 on Terraform use the familiar Terraform pattern, and it works for all sizes of infrastructure, meaning it will work for you here. So my advice to you, if you're getting started with the CDK for Terraform, is to follow that pattern until you can't, or until you have a good reason not to. And we'll see some different areas in this demo where that's the case. So we've got our project here. What's the first thing we're going to do? Well, we should probably hook up to the cloud provider we're going to work with. So I'm actually going to hop over here to our provider registry. And in our provider registry here, any of these providers work, right? Every single one of them, as we have said many times. We are going to be working with AWS, yes, but you could work with any of these if you wanted to. And so for me, we've said it, why would you use a CDK for Terraform? Well, to me, the actual question is, should I use Terraform? And if the question is yes, should I use Terraform? Then the next question is, okay, do I want to stay in HCL or do I want to work in my own programming language? That's where you go to make the decision. And so it's really the first step is, do I want to be able to work with our entire battle tested ecosystem? Yeah, great. Then ask if you want to work in your own language. The only other thing I want to point out before we get started here is just kind of back on that previous mindset. The other reason we're going to stick with the Terraform paradigm is because if you're collaborating with platform teams, if you hand them something that looks familiar, the conversation is going to be a lot easier. So just keep that in mind as well. And then finally, the experience you're going to have is also going to be dependent upon your language's ecosystem. So the TypeScript ecosystem, I'm using Visual Code Studio here, not just because I think it's pretty good, but because they have their wonderful TypeScript IntelliSense plugin here, and we're going to see that help with a lot of productivity. So we are ready to go ahead and hook up to AWS, and we're going to do that with by adding the AWS provider. So I'm going to hop over to my shell here, and I'm going to run the command CDKTF provider add AWS. And hopefully we can see my terminal here. If not, please let me know. And this is going to go and grab everything we need, drop it into our project to start working with the AWS provider. So now I'm going to hop back over to my code editor here. We're going to go ahead and get rid of this line, and we're going to do new AWS provider. We can see auto completion. We can see IntelliSense giving us the documentation right here. So we really don't have to leave our editor. It's also going to import it for me here, which is really convenient. And then we're going to pass the scope, which is just basically how we say what stack, what collection of infrastructure does this belong to. We're going to give it a unique ID. Avoid using UUIDs and hashes. This does need to be a unique ID, but it's more for a human readable one. And then finally, a config map here where, well, I guess this is TypeScript, so it's an object, but you know what I mean. And here's where you could add like your API keys and stuff like that. But for this demo, I've gone ahead and exported all my credentials as shell environment variables, so I don't have to hard code any of those in here. And quite frankly, you shouldn't hard code them either. So we're going to set the region to US East 1. And with that, we're actually good to start using all of the resources that AWS can provide us with. So the first one we're going to make, if we take a look at our diagram here, what we're going to be building out is an ECS cluster. Now, that's actually not pictured in here because it's kind of this invisible force that sits atop of it, but just trust me, it's there. And we're going to make that resource by doing new ECS. I'm going to start typing it. We're going to see that we have that binding here in the provider available to us. And we're going to make an ECS cluster with the scope, a unique identifier, and then an object of configuration options. And the only thing we need is a name. Okay, so I know that I've sort of thrown some concepts at you, and we are going to go back to these main concepts, but I want you to get it under your fingertips first so that when I start talking about these things, you know, it's not just some abstract thing, you've actually done it. Now, looking at this, if we define every single resource in here, this file would get kind of ridiculous, right? So we're not going to do that. We're going to split this resource out into its own file. So I'm going to come over here and make a new file. We're just going to call it ECS cluster.ts. And inside of here, I'm going to just drop in some code, and we're going to walk through it. Now, looking through this, two of these lines should look pretty familiar because we have them in the other ones, and they're doing what you think. They're just making an ECS cluster. But the rest of this is very TypeScript specific. And the only reason it might confuse you is if you're not familiar with TypeScript. But all we're doing is we're creating our own class that's extending that construct concept. And we're making a public property available that is this resource. And the important part of this is, again, it's a way for us to pass this scope, which is, again, just a way to say, hey, what infrastructure do you belong to into here so that we can reuse this. So with that done, I'm going to come back over to the file here, remove some of the stuff we don't need, get rid of this, and we will use our new resource or our new construct here. And this is just some syntactic sugar here to pull that cluster property off there. I believe I called this the ECS cluster. And as I type, we can see that the types kick in and I can see exactly what I need to pass this. All right, so with this, we've actually done the main part of the workflow you're going to use to build out everything else. All right, so everything else we see is going to either be a derivative or an expansion of what we've done here. So with that, let's go ahead and take a little bit of time to cover the concepts you're going to need to start building and architecting, some of which Dan has covered, but I want to give them a little bit more in depth. And there's three you need to know about here: the stack, the resource, and the construct. All right, so the stack, pretty obvious if you have a production environment. If you have a microservices architecture in AWS, that's going to be a stack. It's a collection of related infrastructure. If you have a resource, that one's also probably pretty obvious. It's just an individual building block. But a construct, if when we got to that part of the presentation, you're still a little bit confused, that's fine. Here is our actual definition. Let me read it. Constructs are classes which define a piece of system state. Constructs can be composed together to form higher level building blocks which represent more complex state. If that made sense to you and gives you clarity, give yourself a star. If it didn't, though, let me confuse you a little bit more, because a resource is also a construct and a stack is also a construct. Okay, so what we're going to do here is simplify this with an analogy using Legos. Let's say we have an individual Lego, a full-blown city, model city of Legos, and then also a building of like little buildings of Legos of pre-made things. If you're trying to draw the analogy, you've probably recognized what two of them are. The individual Lego is our individual resource. The full-blown city of Legos is our stack. Therefore, the buildings and the cars, those must be the constructs, right? And you'd be right. And in fact, when you're developing in the CDK for Terraform, that's how you're going to think about constructs the majority of the time. You're going to build out these buildings, these smaller models, and then you're going to compose your city there. And this carries over to the other analogies too, because a stack is technically a collection of infrastructure pieces that are related. Technically, one resource is a collection of infrastructure pieces that are related. And as is an entire construct, say like a VPC, which we will see here, that's a collection. Just like a Lego, a full city of Legos, and a building of Legos are a collection of related Legos. Okay, I promise that analogy will help later, and hopefully that made sense. If not, please drop it in the QA and we can tear up my analogy together. Okay, so that actually takes us right into part 2 here, which means if we hop over, we're going to start building out everything here. Now, if I code all of this from scratch, we will never end. So we're not going to do that. Instead, I'm going to hop over here and fast forward in time like magic. And in here, we'll see that some stuff has changed, just so that we don't watch me code out everything. Well, the first thing I want to show you is on the side here, we have a number of files that have been added. And hey, these are all those constructs. These are all of those pre-made little buildings that we're going to then use to compose our full-blown city in this main file. And then in the main file here, we see that we've got a lot of yellow squiggles. And this is just me importing all of these different constructs into this main file so we can start working with them. So more of like a checklist for me, I suppose here. And that's going to bring us right into where we can start working. There's also some other changes here. The first one is we've got this common construct here that's just holding all of our different variables. So if this is a pattern that if you've worked with Terraform before, that should probably look familiar. In generally normal Terraform, you've got a variables.tf file that then makes those variables available to all of your other different resources. Well, because that's not an immediately easy thing you can do in TypeScript without it being a little odd, we've just made a construct to hold all of those values. So if we open this up here, we can see that we've got like our VPC CIDR and some default tags. And the only thing that the construct is serving as for is just passing through the scope to let these variables know that they belong to a related piece of infrastructure. And then here we can see that we've swapped out the region, the hard-coded region, using some of those variables. And then we've also passed some variables into our cluster here that if we open up that file, is just using those to generate a little name tag prefix. So nothing crazy there. So what is the first thing that we should do? The first thing that we should do is build out our networks, our AWS network here. So that's also generally referred to as a VPC, so a virtual private cloud. And we have a construct built for us here already down in vpc.ts. We'll come back to that file in a second, but let's go ahead and define it. I'm going to make a constant, call it VPC, new network. And this is going to take the scope, a name, and then the variables construct so that we can pull the information off of it. Now let's go ahead and take a quick look at it. Right here, we can see, depending upon your language, for me, at least in TypeScript, this top bit gives you a really nice index of every single resource that's going to be built out with this construct. And as we scroll down, if you're just architecting and not necessarily working on this construct, then this is all you probably need to see. And as we scroll down, we can see something that if you're used to normal Terraform, that should look pretty familiar. We have all of these resources just defined right on this class. When we instantiate it, they'll be there. So we have our subnets, our internet gateways, our route tables, and so on. The only other thing that we'll see here is that instead of using, for example, the for or count property that you would use in HCL, well, we see us using just a simple map function to loop over the availability zones and make subnets based on those. Okay, so there is that. The next thing that we need that is also not depicted in this picture is all of the firewalls, so all of the security groups. And obviously that's very important. And we have a construct for that already made. So we're going to do security groups, if I can spell, and then new security groups. And this construct is going to take, as usual, the scope, an identifier, variables object, and then this is the first time we're going to see us reference another construct that we've used. So we're going to reference the VPC construct, which has a VPC on it. I know that looks a little odd, but it's because there's other things on it. And then the nice thing about autocomplete, as soon as I go down into this resource, we see it autocomplete all of the different properties that I could pull off of it. And I need ID here, so I'm going to go ahead and select that, and that will finish up the security groups. Now, this is kind of the last file that we're going to dive deep into here, just because we're going to see a departure from the usual declarative nature of things and step into something a bit more imperative. If you've worked with any security group files before, you know that there's a lot of rules that get repeated. For example, how many times do you define allow ingress AD traffic from anywhere on a public facing load balancer? Probably quite a bit. And that can lead to some very long security group rule files. So if we look through this construct here, we can see, hey, it's going to export 5 security groups, an application load balancer, and some other ones here. And as we go down at the top, we're going to see some reusable functions that just take a security group ID and add one of these common rules. So as we scroll down, we'll see this more imperative paradigm come into play, where we've got the different security group IDs, and then we're just using these functions to add those, making this a lot shorter. Now, when you choose to do this, that's going to be up to your team and up to whatever practices you have in your code. But I did want to show that is an area of utility that can help with organization. So let's go ahead and go back. If we've got the security groups done, the last thing that we need to make here that's not pictured on that diagram is the IAM roles. And the IAM role that we're going to make is just going to be used to allow monitoring. We're going to set up later to take a look at our clusters information and the container instances so that we can monitor CPU. All right, so now we can actually start building out the components that we have here. We see that we've got some load balancers and the services and the database. We've actually already made the NAT gateway and internet gateway because that's come with the VPC. So let's go ahead and work with the load balancers here. I'm going to grab this, head back over to my editor, drop it in here. Not going to drop in the same thing. That would be absolutely pointless now, wouldn't it? Here we go. And we'll see we've got our 2 load balancers made, and hopefully the pattern is starting to make sense. You go, you make a construct, you define the resources in it, you come back to your file or wherever it is that you're defining your stack, and you hand the information off. Most importantly, the scope, and then an identifier. And then we just see that we're adding some variables, what subnets it's going to be in, what security group it needs, and what VPC it belongs to. So that's 2 of the application load balancers, and you'll see that they're 2 different constructs here. And if we head over to this application load balancers file, well, we'll see that there's actually 2 constructs in this one this time, as opposed to just 1. the thing is we could actually just used one instead of two. We could have just added some more control flow here, just doing an if statement around what makes a public load balancer versus what makes a private one. But again, when you do that, it's up to you. But I wanted to show that if you wanted to be very declarative, you can make an individual construct for every single one of these. Okay, but let's go ahead and code in the silver one. So we'll make a silver ALB here for a silver service. As we see my wonderful naming conventions for my fake services here. This is going to be another instance of the upstream service ALB, and we'll see autocomplete kick in and say we need the scope, we need an identifier, we need the variables, we need the subnets it's going to belong to, which we're going to put them in the private ones. We'll see me just referencing these other constructs and it giving me these tips as we go. And then we need a security group, which is going to be the upstream service, application load balancer. And then finally, what VPC it belongs into. And there we go. If we take a look at our diagram, we've got all of the application load balancers built out, leaving just the database and the services. So let's go ahead and move on to that. So far, we've been defining all of these in as a constant because we need to reference them. But if you don't need to reference them, you can always, of course, just drop it in without setting it to a constant because you don't need to. And our database here is just an EC2 instance. It's actually not in ECS, so it's actually an external instance. And we can see that in my EC2 file here. Why I chose to name this EC2.ts instead of database.ts, I can't recall. So let's just move past that. And that is going to take us to just needing to make those services. So let's begin with the client service here, which is going to be this one. And for ECS, you're always going to need a task definition that is the blueprint for your containers that the service is going to make, as well as the service itself. So we're going to see those right here. Let me fix my indentations here. We've got our task definition, which again is that blueprint. It's going to take some different values. We see us referencing the load balancers to the other upstream services here. And then also the service client. And so this is going to take that blueprint. It's going to take the cluster. It's going to take the load balancer that it needs to hook up to those containers, what subnets are going to be in, and of course, the security group that it's going to front for the service. So since you've seen that, the other two, what we're going to do for those should be just as predictable. And so for time, I am also going to just drop these in here. So let me just grab those and put them in. And there we go. Let me fix my casing here for my own sanity. Okay, there we go. Casing's good, and this should look the exact same because it is. We're just using a task definition, and then instead of using this client service, which if we go to our services, we'll see once again, we have two constructs in here. Instead of using any one of those, we're just reusing the same upstream service for both the gold service and the silver service. Once again, I wanted to point that out because if you wanted to, you could probably make all of these one single construct and just switch on them with control flow. But that is a design decision up to you and your team. All right. And whether you know it or not, we have actually built out everything. This is actually everything except the Datadog monitoring piece. So let's go ahead and move on to the Datadog monitoring piece. So to get that set up, we want to follow the same flow that we did for the AWS one. In the AWS one, what did we need to do? We needed to find the provider. So let's go ahead and find the Datadog provider right here. We see Datadog. And of course, we have the documentation for all of the resources that it can make. But when you find a provider that you want to use, me head back over to my terminal. We're going to run CDKTF provider add, and hey, here we go. We can see my autocomplete showing where I've done this recently, and we'll just run this, and it's going to go grab the provider just like the AWS one, make it available to us so we can go ahead and start building with those resources. So I'm going to hop back over here, and right at the end, we're going to just add in that provider. We'll just call this a new Datadog. I don't have a choice on what this is called because you actually need to reference the thing, the new Datadog provider. And we'll see that when I do this, it'll actually add it in up at the top here, because again, part of the power you'll get to add on top of Terraform is your languages ecosystem. So even though this all is very verbose, you've noticed I've done a lot. Well, I guess I was copy and pasting, so that was kind of cheating, but even when I'm not copy and pasting, trust me, it was a lot less typing. So we're going to see that we need the scope. as well as an identifier. And I'm going to just call this data dog. And then it also accepts a config map or a config object. And this is where you would specify your API keys and your app keys, but we don't need to do that because I've exported those as shell environment variables. Okay, so with that done, we're actually ready to go ahead and start working with the Datadog provider. And what we're going to set up is a monitor to watch our cluster CPU utilization, as well as a dashboard to give us some visualization here. And what I'm going to do is, well, what I've actually gone ahead and done is I've got a file here called monitors.ts. And in here, we'll see that I've gone ahead and made a construct with the different resources that we need. There's 2 in here. And again, with TypeScript, at least for your language, however you do it, but for mine, at least, I can see right here at the top, okay, there's going to be 2 resources in here, a monitor and a dashboard. And inside of here, we're going to see everything that we need for those. Now, if you're wondering, well, how did you know to write this stuff out? Well, just because you know TypeScript doesn't mean you know Terraform, doesn't mean you know AWS, doesn't mean you know Datadog. So figuring this stuff out, that's just going to be if you know how to work with that service. Now, I do want to point out that if you come over to our documentation here and you were to go to monitor, so let's find this Datadog monitor resource, we can see down here in the schema the properties that we need here. So if you're looking for specific examples for your language, we don't currently have those, but those are on the way. But as we pointed out in the earlier presentation, we do have the CDKTF convert command, which takes any HCL file and will convert it to your language. So you could grab this example here, come over to the command line interface and run CDKTF convert on a file. You would need to put it in a file, and then you could see that example itself. However, the nice part about this is if I go ahead and say make another monitor, just call it another one. We'll do a monitor. Well, again, because the CDK team's done a great job at converting the different providers down to types for your language, we just get the documentation right here. We see we need a scope. We see we need an identifier. We see that in the config map that there's a name property and a bunch of other optional ones with the documentation right here. So one of the pleasant parts that I've experienced, at least with using it, is I haven't needed the documentation as much as I would think. I'm going to get rid of this because that would screw up the whole demo. So that's going to go away. And we're going to grab this name, come back over and drop this in. So there's our monitor, and I should probably import the file here. So that should put that up at the top, which it has. And we need to pass it. We need to pass it the scope, a name. We're just going to call it cluster CPU monitor. We need to pass it our variables object so we can pull stuff off of it for its own usage. And then, as if it were poetic, we are going to reference the very first resource that we created, which was our cluster. And when we dive into it, again, we'll see this nice convenient autocomplete here, and we can see all the different properties that we can pull off of it. And we just need the name, and that is going to set up monitoring for us. Okay, so there's one last thing I want to add here before we deploy that, and that is just a simple Terraform output. So let me add that in here. And if you're familiar with Terraform, and Terraform output is just going to, after the deploy is done, make this value available, perhaps to other projects. But the more simple thing for us is it's just going to print it to standard out so that we can go to the DNS endpoint of our client-facing application and take a look at it. Okay, so once again, let me just do a little bit of magic here. Instead of doing what we would do here as a CDKTF deploy, and this would synthesize it down into Terraform compliant JSON, as we saw in the presentation. And then it would go through the normal deployment process. We would get a plan of all the resources we're going to do and a confirmation of whether or not we want to do it. And then it would go forth and make all the things. I did forget, though, at the beginning that the synth command is a really good way because it's that in-between step that will make that JSON if you want to dive into that and take a look around at what that is. And in fact, let me just do that real quick in one of our earlier projects. So the phase 1, just so that I can say that I did it. And if we take a look, we're going to see that I got an error because I stopped at a middle thing. So in fact, let's go ahead and move on beyond that. Anyhow, what would happen here? We would do the deployment, and after we've done the deployment, we would get something that looks like this. If we scroll up, we would see a confirmation. So if you've worked with Terraform before, you would see a plan. Hey, this is all the stuff that's going to be created. as we get through it, we would then see the nice logs of every single thing that's being created. And finally, we would see our output here right down at the bottom. That is our endpoint, the endpoint that we need to visit. So why don't we go check that out? If we go over here, I've got this opened already, and I'll just refresh it, and we'll see, hey, here is the payload being returned from our service. We've got the client reaching up to our silver service, which is reaching up to the database, and the gold is doing the same. And if we wanted to see a nice little UI visualization here, we can see some information showing our different services connecting with each other. So that's great. Let's go make sure that Datadog was created as well. I'm going to hop over to Datadog. You can go take a look at our dashboard list. And so we can see here in our dashboard, we've got our CPU dashboard showing that we are nowhere near 50% utilization because, of course, it's just a demo. And then also, if we head over to monitors, we can see that our monitor has been created as well with a little bit more information. Yeah. So the last thing that I want to go over here is that, you know, going through this file, we got to build with those constructs, and this gives a big higher level overview that you can just sort of reason about, hand off to someone, and they don't necessarily need to know what's going on in every construct, but instead we get this bird's eye view of everything that we're working with here. That's fair. That's, at least for me, very helpful. Okay, so there are 3 parts. Part 1, we set up a project with CDK for Terraform, talked about the main concepts, and built our first piece of infrastructure. Second part, we built out the full-blown infrastructure, hopefully drove home a workflow that you can take with teams. And then finally, here at the end, we added in monitoring and showed how you can use any of the different providers to pull into the same project. And that brings us to the end. I'm going to hand it back off to Dan.
All right, awesome. Thanks, Cole. I'll just bring the slides back up here real quick. Okay. So we just want to leave you with some resources. I know our team has been diligently working the Q&A for us here in the background. Put the camera there. There we go. So some resources for you. We have a number of a collection of tutorials on the HashiCorp Learn site. So definitely check those out. Those will help you get started and learn how to do some of the things that Cole showed you in his demo. The documentation is an excellent resource. It's very detailed. Everything we went over in the presentation and that Cole went over in his demo is covered in that documentation. All of the concepts and the architecture, examples, deployment patterns, everything really covered off very well in that documentation. Again, you can find the project on GitHub, and we'll also include here there's some links to these links. I'll drop them in the chat. They'll also be in the follow-up email, the full links where you can find these demos from the Mozilla Pocket team on how they're using this in the real world. And also we have an engineering deep dive from some of the engineers who are on the call here with us doing some of the Q&A on how under the covers things kind of work, how the runtime works, and how it generates that Terraform configuration. And like I said, I'll leave this up. We'll go into the Q&A here, Kyle. I think we have a few to answer live.
Excellent. Thank you so much for that. We do have a couple seconds for some Q&A. I believe one of the most popular questions was around the concept of a construct, and in terms of what does it kind of relay, or what kind of does it translate to in terms of those things on the HCL, on that side of things for the Terraform side. So I'm not sure if Dan, Cole, or Ansgar or Daniel, that, or since we're kind of running out of time, I can also take it myself.
Yeah, I can also answer. So a construct is can be similar to a Terraform module. So a construct can be a class that extends from construct, basically. So what we saw that called it in the tutorial, and that's kind of a grouping mechanism for all the Terraform resources and resources and so on. So that way it can be the same as the Terraform module. but it can also be something different. So it can be more. So basically, all resources are constructs. All parts of our, like almost all, but most parts of our core library are constructs as well. It's basically this declarative building block that we're using to build the CDKTF program and have something to synthesize into the HCL JSON.
Excellent. Thank you for that. And then since we have, let's do one more question. There were a lot that were focused around, we already have a bunch of Terraform configurations today. They're all written in HCL. So what are some ways that some of the attendees can kind of figure out how to either migrate over or start using CDKTF with some of those existing configurations that they have today?
Yes, so you can generate bindings for these existing HCL modules, which is like the most common way to interact with that in general. And the questions that we answered, we also linked to a talk we gave on the last CDK day that goes into detail of how this co-op world can work. So
all right. And we'll also, we will share a lot of these links that have been added out here as well. Oh. Sorry, I apologize, Daniel. I'm not sure if that was my side breaking up or yours.
I think mine broke up. Could you repeat the question?
It was just wrapping up the tail end of our the conversion from HCL over to CDKTF, or kind of intermixing those. All right, so with that, we're going to go ahead and wrap up. So I do want to thank everyone who submitted the great questions. We're going to continue to kind of work through those, and we're going to work with our hosts here to end up sending out some of the more commonly asked questions as part of the email that comes out with the recording. So I hope everybody enjoyed today's live stream and the newly GA'd Cloud Development Kit for Terraform. To get started with the CDKTF, you can head on over to the GitHub repo or head over to some of the walkthroughs on learn.hashicorp.com. Just look for the CDKTF collection. And then, as we saw in Cole's demo, Terraform Cloud can also be integrated into the CDKTF workflow just as easily as your existing Terraform workflows do today. You can get started for free by heading out to cloud.hashicorp.com and creating a free account. Finally, as we mentioned at the beginning of the live stream, we will be making this recording available after processing, typically within 2 to 3 days. And we'll send an email to everyone who registered with the recording link, and again, with some of those more commonly asked questions. So with that, thank you all again, and please have a great day.